So what is an index, and what are the laws of indices you have to understand? So let's say we have a number given as, let's say, 2 times 2 times 2. So in this case, this is the same as having it as 2 to the power 3, where 3 shows how many times is the 2 is multiplying itself. And there we can also have, let's say, a times a times a times a. In this case, this is the same as a to the power 4. So what is a as well as what is 4? What is 2 as well as what is 3? So now for that case, a is said to be a base, and 4 is said to be a power or exponent, or can be said to be an index. So keep that in mind. So which means we can be able to have to play around with algebra, and for the expressions that involves actually the power as well as the base in those cases. So how do we play around with those kind of expressions that involves the power as well as the base as far as the algebra is concerned? So let's have to venture into what you call the laws of indices, or the properties of the exponents in this actually lesson. So we have the first property, which is said to be the multiplication or product law. So we have what you call the product law. Should be that. So what is the product rule of the actually exponents, or as part of the laws of indices? So what is that one? According to the principle behind the product rule, it is this: that let's say if we have the expression with the same if we have the index expression and with the same basis, it happens to multiply, we just have to pick the single base and have to add the powers. In this case, if we have, let's say, a to the power m and that times a to the power, let's say, n, according to the principle behind, this is the same as a to the power m plus n. This is happening because the bases are the same, so just have to add the powers in that way. And we also have what we call the power product rule. What is the power product rule? So now the power product rule states that, let's say if we have this case, let's say a to the power m and times, let's say, the power m. So in this case, this is the same as having a to the power n times m, where the powers are to multiply one another. So in that case, so that's the principle behind the power product law. And we also have another law that states that, now that is said to be a division law, or said to be a quotient law. So what is the division law? So according to the principle behind the division law, if we have, let's say, a to the power n divided by a to the power, let's say, m. So now, much as we have the exponents with the same basis, it happens that they're dividing. It is the same as having them as this: a to the power n minus m, where the power of the numerator will have to subtract the power of the denominator. So keep that in mind. And we also have another exponential law. Should be exponential law. And what is that one? We have it as the power distribution law. So what is the power distribution law? Let's say if we have a times b in the overall to the power m. In this case, what it means is that since a and b, they are multiplying, it means this power m will be distributed for all. In this case, this is the same as a to the power m times b to the power m. For this case, this is only happens when the expressions are, or actually when the values are multiplying. In other words, you cannot have this, let's say, a plus b and let's say to the power m. You cannot have this a to the power m plus b to the power m. This is wrong. or let's say if we can have a minus b to the power n, this is not the same as a to the power n minus b to the power n. This is actually not acceptable, but that is only being done if we have the values or the expressions that are multiplying. And also whenever we are dividing, let's say if we have a over b, the overall to the power m. So according to the power, actually the power distribution rule, we'll have it as a to the power m divided by b to the power m. So keep that in mind. And we also have what we call the zero power law. What is the zero power law? So in this case, what it means is that if we have a number to the power 0, the answer is given us. So whichever the figure or the number, whichever the value of the expression, and much as it is powered 0, means it is the same as 1. So keep that in mind. And we also have what we call the negative power law. What is negative power law? So according to the principle behind the negative power, let's say if we have a to the power negative n. Now this is the same as having it as 1 over a. So which means the removal of the negative here brings about 1 over that one. So it should be to the power n, by the way. So the removal of this negative, and it makes it that we should have the reciprocal of a to the power positive n. So that is. So keep that in mind. You understand how this one is basically used, but keep that in mind. And finally we have what you call the root rule. What is that one? Let's say if we have a to the power, let's say n over m. So now you can see that the power of the exponent is a fraction in nature. So in this case, the denominator of the power becomes the root, and where the numerator becomes the power of the base. So in this case, this is the same as the mth root over a to the power n, and it can also be expressed as this, and the overall to the power n can be that as well. So keep that in mind. So now let's see how we can be able to apply these laws of indices or the properties of the exponents in some cases you should have to understand about. Let's say we have, and of course before we go further, you should also have to look about this law. What is that one? Self-exponential expression, where the number is expressing itself to have the base as well as the power. And basically we can have, let's say, a 4. This is the same as having it as 2 to the power 2. So now you can see that the 4 is expressing itself into exponential form, whereby it is having the base as well as the power. That is the principle behind self-express exponential form. So let's see that we can have to apply the laws of indices in some typical problems. Let's say we have 4 to the power 2 times 4 to the power, let's say, 5. So now we're having two exponential expressions and that are multiplying, and the bases are the same. It means now this is the same as 4 to the power 2 plus m, actually plus 5. Since the bases are the same, we just have to add the powers. So in this case, this is the same as 4 to the power 7. So that's the principle behind. Let's say if we have a to the power b, that should be a to the power n times a, let's say, to the power negative 2. Now since the bases are the same, it means we'll have it as a to the power n minus 2. That is the actually how it should have to be. And think about this one as well. We should have to see how we can be able to make it up to. Let's say if we have 8 to the power 2 divided by, let's say, 8, let's say, to the power 7. So in this case, this is the same as having it as 8 to the power 2 divided by 8 to the power 7. So using the actual division law, this is the same as 8 to the power 2 minus 7. So now we'll have it as 8 to the power negative, it should be 5. So using the principle behind the negative rule, now this is the same as having it as 1 over 8 to the power 5. So keep that in mind, and of course we should have to express what is this value, 8 to the power 5. Try that on at your own time. So what if we have this case? Let's say we have 2 to the power 5, let's say times the power of x. So now this is the same as having it as 2 to the power 5x. So the powers, you just have to retry and multiply each other there. So take note of that. And how about if we have this case? Let's say we have a 5 to the power a times, let's say, a 2. It should be half. Now this is the same as having it as 5 to the power. Now the powers are going to multiply. I'll have it as a over 2. And of course, using the principle behind the root law, this is the same as having it as a square of a 5 to the power a. So that's how you can have to apply actually such case in that way. Now let's say we have this case, and I think about this one as well. We should have to see, let's say we have 8 to the power negative 2. Now this is the same as 1 over 8 to the power 2. And of course you can be able to have that on out. Of course you have it as 1 over 64. And what if, let's say we have, in this case, let's say we have h to the power, let's say, negative 18 in the times h to the power, let's say, negative 2. So what is this one? And of course we can think of using the principle behind the product rule, since the base are the same. So you have it as h to the power negative 8 minus 2. It should be 18 rather, negative 18 minus 2, which is the same as the h to the power negative 20, of which you have it as 1 over h to the power positive 20. So you can have it as that. Or else you may think of applying, you can also have this one as this. You have it as 1 over h to the power 18 times 1 over h to the power positive 2. And you think of multiplying those using principle behind the multiplication of the fractions. In that case, you also have it as 1 times 1, we have it as 1 over h to the power 18 times h to the power 2. That will be given as 1 over h to the power 20. So you have that and as that. So keep that in mind. Now what if we have this case? Let's say we have this case. Let's say we have a 64, let's say to the power negative 2 over 3. So what is this one? So now, since the power is negative, we should have to apply the principle behind the actually negative power. In this case, this is the same as 1 over 64 to the power positive power. You have that and as that. The next, you should have to apply the root rule, in the sense that this one will be given as the root of a 64 and 2 will be the power of the 64. So which means you have it as the cube root of 64 to the power after 2. So what is a cube root of 64? So now you see that the cube root of 64 will have it as, that is 4. Then to the power 2 will have it as the 16. So keep that in mind. And how about if we have this case? Let's say we have the square of, let's say have the square of x to the power 9 divided by, let's say, 27. So what is that one? Now according to the principle behind, the whole expression is inside the square. According to according to the root law, now this is the same as x to the power 9 divided by 27 the overall to the power half. That is the same as that, and of which according to the distribution law, this is the same as x to the power 9 and that to the power half divided by 27 over to the power half. Now this is the same as having it as x to the power 9 over 2 divided by now 27 to the power actually half. And of course that is the principle behind that. And in this case, you should have to understand that this is the same as x to the power 9 over 2 divided by, you can have it as the square root of 27. So do you have the square root of 27? What is the square root of 27 if we may have it? So there is no square root of 27 you can think about, but we can have to express 27 in a sad form, in the sense that we can have it as x to the power 9 over 2 divided by, now have a 9 times 3. This is the same as having it as x to the power 9 over 2 divided by a 3 root of 3. So that's how you can have it, but we do not have the square root of 27 in that way. And also try these problems at your own time and see how best you can be able to go over those problems. Let's say you have 125 to the power, let's say negative 2 over 3. Try this as well. Let's say if we have 9 to the power negative 3 over 2. And let's say if we have 17 over, let's say 25, and say to the power negative 2 over 3. Try to have these problems out at your own. Let's say if we have, let's say 4x, negative should be like that in the overall, let's say to the power 3 over 2. Try to go through those cases. Let's say if we have 3 to the power 0 times, let's say 2 to the power negative 2. Try to express that on up to. And also we should have to understand what is this. Let's say if we have, and that should be the cube root of, let's say 2 to the power 6. What is the value of that one using the laws of indices? So try to go through those problems. Now, how can you be able to apply the laws of indices in algebraic expressions? How can you be able to apply the laws of indices in algebraic expressions? And if we say algebraic expressions, these are the expressions with the variables in the match of. And by the way, all some of the cases here we have been dealing with, they have been containing actually, they have been having algebraic expressions, so which is fine, of course. But let's think about this one. Now, I can say this is the high level of the exponentials. You should have to understand much about. Let's say if we have, in this case, let's say if we have x to the power, let's say x to the power 2 and that plus 3x minus 2 and that to the power 6. And let's say divide by x to the power 2 plus 3x minus 2. So what is that one? You can see that the overall power here is the 1. So that's what it means there. So we have the expressions with the same basis, as you can see. So which means using the division law, this is the same as having it as x to the power 2 plus 3x minus 2 and that to the power 6 minus 1. And of which you have it as the x squared plus 3x minus 2 to the power 5. So that's how you can have it there. And how about if we have this case? Let's say if we have 2x to the power 2 and y to the power 3 and times z. let's say over the power 4. What is this according to the laws of indices? So now you can see that all expressions here are multiplying, so which means the power will be distributed for all. So in that case we'll have it as 2 to the power 4 x to the power, now we'll have it as 8 y to the power 12 z to the power 4. And of course you can be able to simplify that one much as it is simplifiable. So keep that in mind. And also, what if we have, let's say, this case, let's say if we have, let's say, t to the power 2 and plus 3 divided by, let's say, t to the power 2 plus, let's say, 3 as well. Let's say this one is 2 to the power, let's say, 15. This is to the power 9. So what is that one? So now the bases are the same, so which means we'll use the division in the sense that we'll have t to the power 2 plus 3 and over to the power 15 minus 9. So you can have it okay right there. And what if we have, let's say, x to the power p times x to the power, let's say, q. So now let's say in this case this is the same as x to the power p and plus q, since the bases are the same. So take note of that. And also try to understand this one as well, though you can be able to have that one out. Let's say if we have 8 to the power 2 and times b and c to the power 0 and over to the power, let's say, 3. So keep in mind that, let's say this is the negative 3. So now keep in mind that a number to the power 0 is the same as 1, hence we'll have it as a square and b and over to the power negative 3, in the sense that this one will be given as actually 1. So in this case this is also the same as having it as 1 over 8 to the power 2 times p to the power 3 according to the negative power law. So according to the distribution law, this is the same as 1 over 8 to the power 6 times p to the power 3. So that's how you can have it there. You also have to understand this one as well, how we can be able to have it out. Let's say if we have, in this case, x to the power 3 and let's say y to the power negative 2, let's say times 8 divided by, let's say, x times y to the power 2 and z to the power, let's say, negative 3 and the overall to the power negative 3. So what is that one? So now of course you should have to understand that all these expressions are dividing. Now let's think of using the division law, in the sense that we'll have to deal with x and this, y and y, z as well as the z. Then at the end of the day we'll have to make use of the power in that case. So now this is the same as x to the power 3 minus 1 and y to the power negative 2 minus 2 and z to the power negative 3 minus 1 and overall to the power negative 3. So now this is the same as x to the power 2 and y to the power negative 4 and z to the power negative 4 and the overall to the power negative 3. So now according to the power distribution we'll have it as x to the power negative 6 and y to the power actually positive 12 and z to the power positive 12 as well. So that's how you have it there. You also try to understand this one as well, how we can be able to have it out. Let's say if we have, what is this, 8 to the power 3 and let's say b to the power negative 9 and c to the power 2 divided by, let's say, 8 to the power, let's say, a 2, b to the power 5 and c to the power, let's say, 4 and the overall to the power 0. Now what is that one? So try to understand that one at your level base. You also think about this one as well, how you can be able to have it. You should have to do this one at your own time. Let's say if we have b to the power p plus 1 over, let's say, b to the power, let's say, 0. What is that? and what is, let's say, x squared, x cubed divided by y to the power negative 3. Now should be that divided by x to the power 2 over y to the power 3. What is that? Try to go through it. And also think about this one. Let's say if we have 1 over 3 to the power negative 1, and let's say plus 1 over 4, let's say to the power negative 1. Try to understand that and as well at your own time. And also think about this. That is, let's say if we have 2 to the power negative 2, and plus 2 to the power negative 1, let's say plus 2 to the power 0. What is that? It's to the power negative 2. Try to have to understand that and as well at your own time. Let's say if we have 2x to the power 2, let's say over to the power negative 3, and minus 2 x to the power 2 over to the power negative 3. Try to understand that and as well, and appreciate the way we can have to understand that and up to. And try to have this as well. Let's say if we have 8, actually it should be 2 to the power 8 times 3 to the power 15 divided by, let's say, 9 times 3 to the power 10 times 12. Try to have that one in the proper order. Let's say if we have 144 times 125 and the over to the power, let's say, negative 1 divided by, let's say, 2 to the power 3 times 3 to the power, let's say, 2. So try to understand, let's say these brackets are given. So try to have to understand these cases at your own time, and also try to go through a lot of examples or exercises in different books. You should have to mastermind yourself. You should have to mastermind these things in a proper order. Thank you. But don't forget to subscribe my YouTube channel. Just have to click on the bell symbol that always appears when you open my page. Thank you.